Hi everyone. Today we have a few elevator problems that have infamously given a lot of students some trouble. So today we're going to fix that. Before I begin this problem though, I'd like to go over a few important points that'll help you through these problems. The first being that the scale reading in newtons is equal to the normal force exerted on the person on the scale. The second is, if Fn, or the reading on the scale, is greater than mg, that means the acceleration is upwards. And if Fn is less than mg, that means the acceleration is downwards. And then the final point is that velocity is not important in these problems, as the only thing that matters in finding the force is acceleration. Okay, let's get started. We have an 80 kilogram person standing on a scale on an elevator that is accelerating upwards at 3 meters per second, and we're told to find the scale reading. Okay, we already know that our acceleration is in the upward direction, and we have defined it as positive. So let's start by writing our sum of the forces, which equals ma. We'll draw our free body diagram. We have mg of our person, and we have Fn from the scale, which is also our scale reading. So since Fn is in the direction of acceleration, it's positive, and we subtract mg of the person and set it equal to ma. Solving for Fn, we get Fn is equal to ma plus mg. And now if we plug in, we have 80 kilograms for the mass, 3 meters per second squared for the acceleration, plus 80 kilograms times 9.8 meters per second squared for g. And this is equal to 1,024 newtons. And again, this is both the normal force and what the scale reads. Let's move on. In this problem, we're asked to find the mass of the person standing on the scale. We're given a velocity of 1 meter per second upwards and an acceleration of 2 meters per second squared downwards. Again, if we refer to our important tips, we can see that velocity is not relevant, and sometimes it's thrown into problems to throw you off with extra numbers. But for this, we'll scribble it out so it doesn't distract us. Let's start by drawing our free body diagram. We have mg downwards and Fn from the scale. Our sum of the forces is equal to ma. And since mg is in the direction of the acceleration of the elevator, mg is positive, and we subtract Fn. Let's start by trying to isolate m. We'll add Fn to the other side and subtract ma. mg minus ma equals Fn. Take out the m and divide by g minus a. Let's plug in. The scale reading is equal to Fn, so Fn is 500 over 9.8 minus 2 meters per second squared. And this is equal to 64.1 kilograms. Perfect. In this problem, we're asked to find the acceleration, and we're given the mass, scale reading, and a velocity. Again, velocity is not relevant, so we'll scribble it out. The first thing we'll do is draw our free body diagram. We have mg downwards, and Fn from the scale. Since we don't know which direction acceleration is in, we can use our important tips to help us find it. We said before that if Fn was greater than mg, acceleration is upwards, and vice versa, if Fn is less than mg, the acceleration is downwards. So to figure out which direction the acceleration is in, let's look for mg. mg is equal to 80 times 9.8, which is equal to 784 newtons. This number, 784, is greater than 700. So we know that the acceleration is downwards. Now let's solve for our acceleration. Our sum of the forces equals mg minus Fn. We said mg was 784 newtons minus the scale reading, which is 700, which is equal to the mass of 80 kilograms times our acceleration. So dividing 84 by 80, we get 1.05 meters per second squared. Let's move on. For our final problem, we're told to find the mass of the person, given an acceleration upwards, a velocity downwards that we can ignore, and a scale reading that says 60 kilograms. This problem is a bit different because the scale reading is in kilograms instead of newtons, but this is no problem for us. Let's start by drawing our FBD. We have mg downwards and normal force upwards. Before we write our sum of the forces, let's calculate Fn. Fn is equal to our scale reading times g. We can't use the mass because we don't know what the mass is quite yet. But we'll substitute in the scale reading, which is 60 times 9.8, which is equal to 588 newtons. Fn is also sometimes referred to as the apparent weight, or WA. Now, let's do our sum of the forces. The acceleration is upwards, so Fn is positive. So Fn minus mg is equal to ma. Let's solve for m now. Fn is equal to ma plus mg. We'll take out m and divide by a plus g. So m is equal to Fn over a plus g. When we substitute, we get 588 over 3 plus 9.8, and this is equal to 45.98 kilograms. I hope these tips and problems lessened your fear of the elevator problems, because they can be quite tricky sometimes. And as always, thank you for watching.